For this discussion, think about the value of either a mean or the value of a proportion that you don't think is correct. So I'll give a couple of examples. My parents always told me that the mean time it takes to get to my grandma's house was 90 minutes. That was always the assumption we were under when we were packing up and getting ready to leave for grandma's, is that the trip is 90 minutes long. From my personal experience, I would challenge that mean. I think we actually got there faster than 90 minutes. So I would want to test the alternative hypothesis that the mean is actually less than 90 minutes. Another example, I read somewhere that the proportion of cars on the road that are red, the proportion of red cars is 15%. Just from driving around and kind of looking at the color of cars, I think there's more than 15% of red cars. I could be right or I could be wrong, but that is a proportion that I would like to challenge. I don't agree that it's correct. So my alternative hypothesis would be that the proportion is greater than 15%. And then to take it a step further, you really want to talk about testing your hypothesis and what a type 1 or a type 2 error would look like. So if I was testing the amount of time it takes to get to grandma's house, I would test by looking at a random sample of trips to her house. And that random sample could indicate one of two things. It could indicate that 90 is the mean, in which case I do not reject the null hypothesis. Or that random sample could indicate that the mean is less than 90, in which case I do reject the null hypothesis in favor of the alternative. And now a type 1 and a type 2 error is really going to depend upon the reality. And we don't know the real mean time it takes to grandma's house. If we knew the real time, the real average for every trip ever to grandma's house, we wouldn't be performing this hypothesis test. I wouldn't be questioning the value of 90. If we knew the real value, there's nothing to test. Whenever you're performing a hypothesis test, it's because we don't know for certain what the real value is. And so we're going to draw our random sample to help us decide whether to reject the value that we currently believe or to stick with the value that we currently believe. And so let's say this is our underlying reality, that the mean time really is 90 minutes. Well, then most random samples we take will agree with this. Most of the time the samples will reflect the real population, they'll reflect the real mean, and so most samples would agree with this. But occasionally you'll get a rare or an unusual sample, and it would indicate in this case that the mean is less than 90. It'll go against what reality is, and it'll make us reach an error, a type 1 error, because we'll reject the null hypothesis when in fact the null hypothesis is true. And so in this situation, the ramifications of that are just that we're going to show up late to grandma's, because we're going to incorrectly believe the mean time is less than 90 when in reality it does take 90 minutes on average to get there. If this is the real reality, that the mean time is less than 90, most samples will agree with that. But occasionally we'll get a sample that causes us to make an error. An unusual sample will indicate that 90 is the mean. This is a type 2 error. It'll cause us to not reject the null when in reality the mean time is less than 90. And so the ramifications of this type of error, a type 2 error, would be that we're probably going to show up to grandma's early. Often we're going to show up early because we're going to plan for the full 90 minutes, but in reality, the mean travel time is less than 90. So me personally, I think showing up late is worse than showing up early. So I'd want to set up my hypothesis test to really try to minimize making a type 1 error, because I wouldn't want to falsely reject this, which would cause me then to show up late.